Okay. That's true, Spectre. You know, it's 11 in the morning here, but we all are asleep. I've heard of sleepwalking, but have you heard of sleep streaming? Did my announcement come off? It did. Okay. Um, I want to take another whack at problem 2, I think. Because I had kind of an idea for it. I mean, I wouldn't say I leveled my barber skills. I would say that I gave myself a buzz cut, and that was very simple. So I think it is an upgrade from what I had, but I think it's an easier haircut to do. Hey, okie dokie. Ooh, and thank you for the streak. No, no fade. Just straight up same guard size all over. Yeah. It's not hard to be better than my last try. See the silver lining? Yeah. Conditional probability? I probability is not my strong suit in general, I would say. Um it's kind of about narrowing down, like when you do a conditional for probability in general, you have this, like, they call it like a state space sometimes or something, of like all the possible outcomes. And the thing you're really doing with conditional probability is you're just like narrowing down that universe to just a little like part of it, and you're pretending that that's your entire universe. Oh, with Venn diagrams. Okay. Yeah, same Spectre. I'm not that good with them. How do Venn diagrams work for conditional probabilities? Remember how they I think if you want to give an example of one of a problem that might help. I guess for a Venn diagram, you'd have two bubbles, and whatever your condition is, you would just live inside whatever that condition is. So if your condition is that you are in both, or that both things have happened, then you live inside that intersection, I guess. The rearrangement rule. I need to look that up. I don't know what that is. Maybe this is Bayes' rule that you're talking about. Or maybe it's a multiplication. So does your rearrangement rule look like this? This is my first guess for what you're talking about. Maybe I need to zoom in also. I don't know why there's a Kendrick song in this playlist. I set it to um it's a Spotify radio station for a song that I like, but it's not a rap song, so I don't know why Kendrick got thrown in there. always find the intersection if not already given. Well, this doesn't involve intersections. Maybe you're talking about a different rule. Good song for a bad day. I've listened to lyrics to this song, to be honest, but like the vibe of it is definitely pretty like melancholy. I agree there. Oh, that's what you're told rearrangement is. Yeah, I was just. Oh wait. Oh, funny. So um, usually they maybe it's called the rearrangement rule because it's a rearrangement. Okay, yeah, that may. Um, normally they teach you the formula kind of with the union on being the thing that's like isolated. The way that you wrote it is also completely valid. It's just like a maybe different intuition for it. Um, so yeah, if you want to find the intersection, you can definitely do that though. Like, there's nothing at all wrong with this formula. I never had to. I can think of time I've ever used the formula like this, but maybe there is a situation where it's a good idea. Um, maybe there's another way to find the intersection with conditional probabilities though. So maybe they're trying to avoid being confusing. I might get this slightly wrong, but we saw it on the web page we were just looking at. It's something like this that also involves an intersection. So maybe they're just trying to avoid like getting people potentially confused with that one. I think I got it right. What? Oh, I almost did something terrible with my OBS. Yeah, I guess like maybe they don't want to be confused with that law there. Hey, color cone. So was your original question? Does rearrangement rule always find the intersection if not already given? Yeah, so it does always give you the intersection as long as you know the other three pieces. Um, yeah, so yeah, so that's like the first formula that I wrote here. These two formulas are the exact same thing. I would only really memorize one of them if you're gonna memorize anything, because you can always look at the information you're given and just like let's just throw the rearrangement rule out for now. If you only remember this one, the addition rule, if you're in a situation where you don't know the intersection, just fill in the other three pieces and then solve for the intersection, or just flip the ends. Exactly, yeah. Like if the union is like 0.6 and each of the individual probabilities is like 0.25 and point. I don't have good intuition probabilities. I don't know if it should be more than 0.6 or less. Probably more. So let's call that one like 0.4. Yeah, please do give an example. That would help me a lot. While you're working on that example, I'm gonna look something else up for this problem that's at the top of the screen. Well, actually, um, right, as color cone says, that's the purpose of this like subtraction here. So for this PD problem at the top of the screen that I'm working on, while we wait to see Okie Doki's example, I was curious what would happen if we threw a Taylor series at this U function. I don't know if it's going to help, but we use a Taylor series to do something else in class, and I'm curious if it will be helpful here. It does have it does organically get us the Hessian that Colorcone was saying is helpful to do it in a cleaner way than what I'm probably trying to do here. I'm trying to do it in a way that works in my mind. Okay, and see we have Okie Doki's problem here. Max says these probability things kind of make sense intuitively. Think of them as area. Area of A and B is the area. Right. And it's kind of cool because I think that builds into measure theory really well, that intuition. I think at least. I don't really know measure theory, but do you use the formula sheet for the exam? Oh, good. Memorizing things is terrible. Right, it's like a special type of measure. Like, I guess the special part is that you require it integrates to one rather than like a finite number. Any finite number, I mean. Okay, so if they're independent, I need to remember if they were disjoint, um, there's like a certain case where you can just chop off this thing because it's zero. I think that must be disjoint though, not independent, right? So yeah, okie dokie. I'm a little rusty on probability, so I do need to look things up, but I know that I can eventually figure this out. Hey Leo, probability measures are with total measure one. Right. Funny enough, entropy, differential entropy, as well as mutual information are signed measures. Ooh. Three events with mutual information. I never heard of mutual information. Hey, Aeneas. I think you use the multiplication rule. Have we... The multiplication rule, is that the one with the conditional? It's just the right... Thank you, color cone. And that's the multiplication rule. Yeah. Okay. Thank you both, Max and Color Code. I should really be better with probability than I am right now. I used to be better. Okay, so, and that's why the multiplication rule that Okidoki is speaking of. Yes, right. So for two things that are independent, we know that PA intersect B is PA times PB, peanut butter. The information is like shared, is like entropy such information shared between two events, or even three or more. Oh, that's interesting. So because we're given that these things are independent, we're allowed to use this formula. So 0.4 times 0.7 is 0.28. And now we have everything we need to draw Venn diagrams. A, B. So we just found the intersection, 0.28. There is a little bit of a tricky thing here. So we know that this entire circle is 0.4. But when we go in to fill in the Venn diagram, it does find you the middle as long as they're independent. So the middle part is just P intersect or A intersect B. You can find that however you like, either with the multiplication rule or with the rearrangement rule, whichever one you like. But it's just whatever A intersect B is. Or A and B, right? So either way works. It just depends what you're given in the problem. In this problem, exactly, yes. In this problem, we want the multiplication rule because we have three pieces of information. We have PA, PB, and independence. So that's the exact situation for this rule here. If we were instead given PA, PB in some value for A or B, you know, just pretend like 0.2 or something, then we would use the rearrangement rule. So everything depends on what you're given. Independent is multiply, right? Hey, Xerxes. In information theory, it's often used a lot more than entropy, such as differential entropy, essentially because it works with discrete random events and continuous ones at the same time. Ooh, cool. Or visual intuition pictures independent events being separate, so you pictured two separate circles. Exactly, yeah, Leo. That's the exact question that I was struggling with in my head. So I'm gonna start to color code this just to hopefully make it more clear what exactly I am labeling here. So 0.28 is that area in the middle there. The next thing I want to find, I assume this is going to be important. Maybe not. Again, I'm a little bit rusty on this type of problem, so I might go down the wrong path initially, but if we want to get this area of this like portion of the circle here, we know the entire circle A, 0.12, right, perfect. No need to explain that further then. You got this. Do the same thing for B. Uh, 0.7 minus 0.28, math, 0.42. You work with mutual information, I x1, x2, z is equal to I x1, z plus I x2, z. If independent, so it's additive. Oh, cool. Okay. 0.42, right? Okay, so first step, P of A union B. Math, yes. Hey, famished. Prepping to do math yourself? Hell yeah. So we can do for P of A union B. Oh, that's true. That's a good point. We should find the outside. .18. Why isn't my brain working? That's 0.4, 0.82. I agree with 0.18. Perfect. I think sometimes called this like U for universe or something. Yeah, exactly. Add them up and -1. That's what I did in my head too. I would never do math myself. I don't mind if others partake. Hey, that's very respectful of you, Leo. More algebra, noise. That's the easiest step here? Yeah, fair enough. Okay, so now we can go for A union B. And you actually kind of secretly just found this. So we can either use the, I think you called it the addition formula, but it's also just these three probabilities added together, and we already calculated that once, so it's going to be 0.82. If you prefer, though, we can verify from the addition formula. 0.28. And this should be the same number. What is that? 1.1 minus 0.28. Yeah, that I'm not off. That's the same, yeah. So if that's hopefully you agree with that for A union B. Hey, Aditya, I'm doing good. How about you? Some named Leo lectures would never do math. It's true. My non-math brain is thinking I choose A or B. No, I think that's good. Okie dokie. It's a probability of. So the word or is tricky because or in math has a more precise meaning than or in English. So like if I ask you if you want a burger or a hot dog, it's implied you should only choose one. But if I ask you the probability of A or B, it could also be that they both happen. Yeah, so oh, Adia, I just cut my hair because it was getting in the way, basically. And I got sick of paying barbers because haircuts have gotten super expensive, so I just buzzed it. Do physics. Ooh, I do enjoy me some physics. I thought it's talking either choose 0.12 or 0.42. No, so most you pay for a haircut was 60. That I believe that that's why I saw the barbers around me trying to charge $60, and that's what made me cut my own hair instead. Like an English answering a negative with a negative doesn't reverse it. It means you agree. Do you not want a burger? No, which means you don't. Oh, that is how people talk. Yeah. Yeah, it might be easy for you, but it's not easy for someone who's just learning this for the first time. So I don't think it's right to call questions easy. Um, ups and oh, in Chinese. That's interesting. Do you Like, do you actually speak Chinese, Leo? First and last time I want to go? There you go. Okie dokie. I'm gonna catch up with Chad and then I'll get back to solving this. You speak a little? That's awesome, Leo. You can also solve these problems by writing probabilities in a probability tree. A, B, B prime. Ooh. Yeah, I think I haven't seen that used for this type of problem exactly, but I've seen that in other contexts, Max. That's neat. That's neat. High school physics are low, so you can go. Yeah, no, it's still physics. Okay, so we have a. Okay, so we're talking about like the meaning of A union B or A or B. What they want is the sum of this area here. Like they want the entire Venn diagram. They're not asking. It's like inclusive or versus exclusive or. In math, it's always inclusive, so it could be both A and B. Hey, Dev. Here's a constructive theorem from linear algebra. And any finitely generated vector space does not admit a basis? Oh my god. That is that actually in a textbook somewhere? It'll just be a bad burger? True. Exactly. 3 numbers added up. And if you want to just not think about it intuitively, if you prefer to memorize a formula, just use this formula here. It would get the job done perfectly. But intuitively, it's just these three numbers added up. So people's brains work differently. I don't know which one is better for you, but hopefully one of those ways works. So in constructive logic, they don't have the law of extra. Oh, you mean excluded middle? So not the same as removing not. Wow, that's crazy. Okay. So assuming we're all good with A union B, okie dokie, I'll move on to A prime, which is not A. Naughty, naughty. So, as the name implies, it's everything that's not inside of A. Where's my cursor? Oh, there. I can't see this blue very well. I should choose a different color. So we want the outside of the universe and also B. We are avoiding this intersection area because that does include A. So we're hitting this 0.18 here, and we're hitting the 0.42. Going to JetBlue all day. Hashtag ad. Oh yeah, a D. Yeah, that's actually a lot faster too. I'll show both ways. So doing it the way that I said, we're adding up the 0.18 and the 0.42. Okay, and so that's the formula that Aditya gave. So yeah, you can also do 1 minus the probability of A. And we're given that as 0.4. But these two numbers are going to be the exact same. 0.6, 0.6. So whichever way makes you happy there. Like when you draw I was explaining the Venn diagram way because they asked us to draw the Venn diagram. We could find all these probabilities without ever drawing it though. So yeah, the question asking for A, is it both 0.12? It's both. And so, because these are both included inside of A, or if you don't want to think that hard, just go back to the original wording of the problem, and we know that P of A is 0.4. Hey, Rex. If you make every game a life and death proposition, you're going to have problems. For one thing, you'll be dead a lot. that that's odd phrasing for a fortune, but I think there's some wisdom in there. Yeah, I've definitely seen the Venn diagram way before as a tutor. I don't know if I was taught it as a student, but it's a nice way of like representing probabilities. Is this the most effective way? Venn diagrams? I like them as like I think they're a nice device to not to make fewer mistakes when you do math. Again, it all depends on the person and your personal preferences. Um, but I think having this like visual representation of what probabilities mean can definitely help out a lot of people to think about probabilities properly. But yeah, most effective depends on the person. I don't think that there's a universal best way. I didn't know that formula, Aditya. I would definitely rather do that the Venn diagram way than just memorizing that formula. Okay, so I guess I'll move on to the next one. A prime intersect B. If it's asking for B prime, that'll be 0.3. Perfect, yeah. And so you can either do 1 minus 0.7, or you can do 0.18 plus 0.12. Oh, okay, fair enough, Aditya. Pulling B from the question itself. You can do either. So, sorry, I hope I'm not making this more confusing by giving you options. Um, but you can pull B straight from the question, or you can do it from the diagram. They both work. Oh, fair enough, Rex. Yeah, I honestly I almost never check my Steam requests. I usually only add people if I'm planning to play a game with them soon though. 8, Ayush. Yeah, I am. I just happened to wake up early. Okay, so yeah, like this 0.42 here is not B. It's just a piece of B. It's just like that, you know, moon shape, I guess. Like P of B, it is 0.7. It's only ever one thing. Um, you're getting 0.58. Where is 0.58 coming from? Oh, because you're doing, yeah, so 0.4, yeah, okay, so that's what I was saying. So, um, P of B is always 0.7. We can get it from the diagram by doing these two added. And that gives us the 0.7, and that agrees with the 0.7 up here. It's 11:43 in the morning for me. Yeah, that's the confusing part of the Venn diagram. That's why I tried to do this color coding to be a reminder. B is the entire circle here though, not just one of these numbers. It's both. B is Borgor. So yeah, uh that is a confusing part about the Venn diagrams. I'd say that's like the downside, because that's a very easy mistake to make. Yeah, exactly. It can be confusing for where the different numbers come from. So yeah, if you turn out not to be a fan of the Venn diagrams, I would like draw it if you have to, but just instead rely on the formulas and not try to interpret it visually. If you turn out not to be a fan of the Venn diagram. Um, A prime. I haven't worked this out yet. Let's find out. Oops. Oh no. Okay. Uh, so A prime is everything not including A. So this, and then we're intersecting it with B, which is this. Well, actually, maybe we should do two different colors. Magenta. So the part where the magenta and red overlap, this is a lot of colors, but 0.42. Yes, perfect. I agree with your answer there. You can derive the formula for two general events A and B with the help of the Venn diagram and plug in the values. Right, Ayush. Talking not A intersect B, probability of A is there. Yeah, right. Adia. We're just trying to like... That's basically what we're doing, I think. Yeah, pretty much okie dokie. Like, this is the technique we're going to use for all of these. The conditional probabilities will... like, we can still use the Venn diagram. We're just going to think about them a little bit differently. Okay, yeah, so... let's go there. P of A... yeah, P of A given B. So if we're given B, it is yet another formula. So yeah, maybe we should start by writing that formula down. It's P of A intersect B, or P of A and B, over P of B. And so we could just plug and chug that. Let me make sure I'm getting the formula right. Yes, I am. But my dad finally comes home given I still think about him every night. Aw. It's 100. Just hold out hope. I think that's good advice. Okay, so if we plug and chug, we have 0.28 on top, divided by 0.7. I'm gonna bet that's 0.004. I need a calculator for this though. It's probably 0.04. It's 0.4. What the heck? Never mind. P of A given B. Probability of A. Wait, this doesn't make sense. Maybe it does. The way I was going to explain it visually, see ya, Adia. I thought the visual explanation for conditional probability is that Our universe is B? Oh, yes, this does make sense. Okay. So the visual explanation for conditional probability is we now pretend that our entire universe is B, and we're asking what part of this new universe does A also occupy? Thank you, Aditi. I'll try. It's Milky. Okay, yeah, that's our galaxy at least. um, fair enough. So let me. This is actually a good. I should draw this separately. Um. So this is B, and we have this little intersection part with A. So we're restricting ourselves just to this circle, and we're asking what part of this circle does A also occupy? And it's this little intersection region here that we said is 0.28. So, but we can't just like take 0.28 at its word because our universe has changed. So we need to remember that the entire circle of B is 0.7. And so this isn't gonna be a good explanation, but to convert this 0.28 into this like new universe, we have to divide it by the total probability of B, which is 0.7. Okay, that's completely fair. Because yeah, this is possible to do with Venn diagrams. It's a little bit tricky. So I don't blame you for just sticking with the formula. Okay. So yeah, P of B given A is gonna be the same procedure. This top probability is the same thing. Like, it's exactly flipped. B and A is the same thing as A and B, so that probability is the same 0.28 from before. And then A is 0.4, which again, either get it from the original problem or add up these two numbers here. And surely this is 0.7. Dev, if you're able to fit it in a YouTube chat, that works. Otherwise, put it in my Discord. And so we can work through that last one too. P of A given not B. That's kind of mean. Oh, true, Max. Ha! I forgot about that. Um, Dev, math or homework help or math discussion. Either one is fine. I forgot about that property with probabilities, Max. You're completely right. I mean, we can check it based off our answers here. A given B gave us A. Oh, I think you did flip it, but other than that. You'd have one question mark given just two events. A given B is 0.6, B is 0.3. Oh, okay. So Um, I would use the same. Either one of these two formulas would get the job done. Um, so I'm just gonna choose the top one for fun. Um, you, we can arrange it first, or we can just plug things in directly. I'm gonna plug things in directly, I guess. Actually, I'm sorry. Only the top formula works. I had a brain fart. We're given the probability they gave us is A given B, so we need to use the one on top. If we plug the numbers in that we're given, it's 0.6 is equal to P of A and B divided by P of B, which is 0.3. And so if you're comfortable solving, if you're comfortable with algebra, you might not be, and I apologize. We can talk about this as a different formula, but I'm going to multiply each side of this equation by 0.3 because that cancels the 0.3s here. So what we end up with is this is 0.18 is equal to P of A and B, and that would be our answer. The multiplication one, I get the names of these rules. Oh, this one, no. Wait, no, we can't use that one because they're not given, we don't know if they're independent, unfortunately. This conditional probability one always works. And so if you'd rather have a formula to memorize than doing what I did here, I would just tell you that the thing to remember is the intersection is also equal to P of A given B times P of B. Yeah, and that's what I'm getting to. 0.6 times 0.3. P of A given B means which part of A? Right. Ayush, I agree. Dev, I'll take a look at what you posted. Oh, that's a long question. I'll look at that once we're done with this conversation with Okie Dokie. No. So, if for multiplication rule you mean if this is the thing that is the multiplication rule, do not use this formula. You would get the wrong answer. This formula would give you 0.3 times 0.5. And that's not the same thing. The reason we have to use this one on top is because the multiplication rule here is only for independent events. So, is this the multiplication rule? Am I remembering it right? Max, Okie dokie asked a separate question. This was the... Yeah, so... Um, no worries. So yeah, because they don't tell us they're independent, so we can't just assume that. The multiplication rule is only valid if they are independent, and we're seeing we're actually not. Because otherwise these would come out to be the same thing, but they don't. Hey, Stooky. Something about Calc 2 level, what's the mechanics of proofwriting? Um, hmm. I haven't been through a textbook for proofwriting myself. I bet that color cone would know of one. I've recommended one before that was from that open textbook library, but I didn't look through it very thoroughly. Um, I don't have it offhand. Um, no, okie dokie. Your instructor is correct. What you were saying in chat is potentially wrong. The I want to make sure you know where the 0.6 from 0.3 comes from. Because, and I'm not sure. I'm afraid that I'm misremembering what you meant by multiplication rule. Um, so I guess like, do not use this formula. Do use this formula. I just want to make sure you know like where the correct result is going to come from. Um, this formula always works. The issue is they don't always give you conditional probabilities, so sometimes you have to use this. Um, so unfortunately, it's not one formula. You have to know them both, and when you're allowed to use which one. Well, you're always allowed to use the first one. You just might not have the right information to use it. The book of proof might be the book that I'm thinking of. I'm still trying to find it. Yeah, I think it was the book of proof. So I didn't look through it all that much, but this is potentially another one to consider. I don't have much experience with. I never even had taken a class on proof writing, to be honest. Closest thing I ever got was discrete math. um, yeah, fair enough. Okie dokie. So you don't have to deal with it. Um, I think so. Okie dokie. Like, you seem to be getting it. And probability in general is just it's a really tricky thing. So, um, the parts that you're confused on are really natural to be confused about. Um, I've made Dev wait for long enough, I think. So I think we should at least read through Dev's question and see if we can do anything with it. Ooh. Oh, it's gonna bother me. 1 minute. I gotta do some construction. There's a better way of doing this. Oh no. I think there's such a better way of rearranging the things here than what I'm doing. But I'm gonna do it this way. Okay. Since formulas are given, how should I remember what they are called so I can write down what they do / what they find? So that's another word depends on how your brain works. The way what I would recommend is uh if you're given all these different formulas and you need to figure out which one is right, let me just write down like the two examples we were just talking about. Like you have these two formulas and you're not sure which one you want to use. Look at the problem statement and try and like they're going to give you certain pieces of information. If they tell you, you know, given P of A given B equals 0.2 and P of B equals 0.5, you're given the two pieces of the puzzle for the second formula, so you should use that one. So I would look at the information that you're given and figure out like which formula matches with the information that you're given. There might be a trick where they want you to rearrange a formula, or you might not fit with any of the formulas, but you can find one of those pieces. But yeah, that's kind of like what I would recommend doing. Like, do extra math on the test, use all the formulas applicable. Well, I wouldn't use all the formulas. I would try to figure out the right formula. In this case, the second formula is the right one because they give us P of A given B, and you should use that piece of information when you solve the question somehow. And so this second formula is the one that uses that piece of information. They don't usually just give you extra information for no reason. So I hope that makes sense, but I think it was like a question of matching. Like we have P of A given B, P of B. This formula has P of A given B, P of B. We don't know P of B, or sorry, we don't know P of A, so we couldn't possibly use the first formula. There's just no way to like set it up. Got a nice probability in stats book by Wang. Study when I finish all this grad stuff. Ooh, nice. The simple way is, let's say you have like 1/3 plus 1/5. You might end up doing extra math or slightly harder math than you have to, but the simple way is to just take the 3, multiply it by the other thing, take the 5, multiply it by the other thing. So like you just multiply them by each other. So the 3 gets 5 divided by 5, the 5 gets 3 divided by 3. So that gives you 3/15. Sorry, it gives you 5/15. Plus 1 over, oh my god, 3/15. And so, and that's even the right way to do it for this situation. The part where you end up doing extra math potentially is if you have something like 3/4 plus 1/6. You can do the same exact trick, just, you know, take the 4, multiply it with the other thing, 6/6. Take the 6, multiply it with the other denominator, 4/4. And you'll get 18. The entire fraction, yes. Or you have to multiply the entire fraction. There is no other way. (18/24) plus 4/24. This gives you 22/24. So the downside of doing it this way is that it doesn't always give you a simple fraction. This should be simplified. There's a 2 in common. So 11 and 12. Multiply the outliers. If that's a phrasing that works for you, yeah. Just like take the two denominators and multiply them by the opposite one. Oh, you don't have to simplify. Oh, perfect. That's very kind of your instructor. Yeah, so... Oh, good. Okay. But yeah, so that's like the simple and straightforward way. Just multiply them by the opposite denominator. I assume it's not financial math that Okie dokie is talking about. When solving for the Venn, if I get a number over 1, I know it's wrong. So what you mean is like in this Venn diagram, if you got like instead of 0.12, like if you got 3/1, that would definitely be wrong. Your denominator should always be more than 1 for probabilities. If the outside number is higher than 1. Okay, in that case, it doesn't have to be wrong. I haven't really seen that much, or I haven't really seen that way of doing it. They're not quite probabilities in that case. You can convert them to probabilities. I think it would. It's probably valid. If like the number outside is maybe 10, I think you could have like a 5, an 8, and a 2 or something. You could convert these all into probabilities. I've never seen it presented like this. But this... You could get probabilities out of these. That's what should happen. So, in this Venn diagram that we made here, all 4 of these numbers sum to 1, and that's what makes them probabilities. If they don't sum to 1, you can convert them to probabilities, but they aren't directly probabilities, like, without doing more work. Okay. Sounds good. Okie dokie. Thank you for the questions. Good luck with your studying and with your test. No worries. Okay, so Dev, I'm sorry for the wait. I hope you're still here. I'll look at your question now. Type your name in chat. Oh, never mind. I won't type your name because when I type at, nothing pops up. That's annoying. Okay. Um, yeah, you can definitely make the calculator do like all of this work like here. The calculator can just do for you. The actual like uh, uh, arithmetic. Yeah. Okay, so we have a two-parter here from Dev. These are three questions we're gonna have to answer. Okie dokie. Um, this looks like a financial math type of question. Investment company, win lose, recruits employees to trade in the share market. For newcomers, they have a 1-year probation period. Employees are given, I don't know what that currency is called, but RS1 lock per month to invest in the way they see fit, out at the end of every month using the following criteria. Total loss in any span of 3 consecutive months exceeds 20,000. Their services are terminated at the end of the 3-month period. Harsh. Total loss in any span of 6 consecutive months exceeds 10,000. Their services are terminated at the end of that 6-month period. Rupee and rupees? Oh, okay. Thank you for letting me know. Further, at the end of the 12-month probation period, if there are losses on their overall investment, their services are terminated. Ratan, Shri, Tamal, and Upanshu started working for the win-lose in January. Hey, Sakno. Ratan was terminated after 4 months. Shri was terminated after 7 months. Tamal was terminated after 10 months. Upanshu was not terminated even after 12 months. Table below partially lists their monthly profits in thousands. That's important. Over the 12-month period where X, Y, and Z are masked information. Negative profit indicates a loss. Value in any cell is an integer. Illustration. As Upanshu is continuing after March, this means his total profit during January to March, Upanshu 2z plus 2z plus 0 is greater than or equal to 20,000. Yeah, I always think of Zelda as well. He is continuing after June. His total profit during January to June is more than negative 10,000. Total profit in April to June is more than 20,000. Okay. We can handle this, I think. So, no worries. Okie dokie. Where these names coming from? Probably whichever country uses rupees. Okay. So what is the best that can be said about the value of x? And let's get the table in here too, actually. India, Pakistan, Nepal, Sri Lanka. Oh, wow. Mauritius and Seychelles. It's a lot of countries. The best thing we said about the value of x. So we have x. We have an x here, an x here, an x here, an x here. We have a lot of x's. Ooh, I gotta see that. Ooh, that is a cool flag. You never see flags that have like colors going at an angle like that. Okay, so we want, I guess the best thing we said about x, I guess we got to go through all these situations where we have an x and figure out the inequalities. Are there more flags like that? The passage above the table? Yeah, Yushi, I'll show it for a minute if you don't mind taking a screenshot if you want to keep a copy of it. So I'm not going to be able to show it for like the entire time here. All right, I'm gonna done. Okay, cool. Thank you for doing that. Okay, so let's think about this x first. Raton. Oh, I actually I should have been reading the passage because I just realized I need information from it. um. How do you get? Why does Raton have a fourth entry? Shouldn't there only be 3 entries? I guess they stay on for a month after. They get... Okay, that's a little bit weird. I feel like we're given extra information there. What we know is that these 3 numbers, Raton was terminated, which means Raton's profit minus 20 minus 10 plus x, it must have been less than negative 20. Do we care about strict inequality or not? I'm going to say strict. I don't think it's a big deal, though. So let's solve this for x. Crest from the medieval times. Ooh, those could be cool. So x must be less than 10. Right? I know how to do basic math. Yeah. We can eliminate D. Probably. Yes, in Twitch Trader. Losses exceed. Yeah, but then in the illustration, they still used or equal to. I guess, but you are right, Max. With the way they worded it. I think either way, it's a multiple choice question, so we don't have to be like too picky. But that is true. Okay, so where else do we have? We have an x here that we could work with. But there's also a y in there, and we don't know much about y yet. This row here looks appealing to think about next. because we know what must happen in this 3-month block. The same exact rule. So minus 10 plus x over 2 is less than or equal to minus 20. X over 2 is less than or equal to 0. X is less than 0. Interesting. Well, that contradicts all of these options, right? Did I flip an inequality somehow? Oh, wait, I'm sorry. This person stayed on. That's why. Jeez. What's this person's name? Tamal. Tamal did not get terminated, so his profits must have been more than minus 20. You're watching an interview today. If you like French culture, like to think geometrically and like algebra, you're probably going to be an algebraic geometer, according to Joe Harris, Ravi Vakil's advisor, who wrote the Rising Sea book. Oh, the Rising Sea book makes another appearance. Okay, and so they do say in the passage that the value in any cell is an integer. So as soon as we see an x over 2, we do know that x must be even. Which doesn't really narrow it down at all, because these all say that x must be even. So it sure seems like it's option A. None of these other options could possibly work with what we've done here, because we know x is less than or equal to 10 and greater than 0. So the first one is option A. Only Friday after April, so Jan, Feb, Mar is fine. Feb, March, April gets some. Oh, is that really? Oh, I see what. Okay, I was misreading this. Oh my god, I thought. Oh my god. Okay. Yeah, Dustin, this is not my favorite type of question. This is a kind of a tedious one. Well, we're doing it because Dev is asking, but I don't think this question is very instructive, to be honest. Thank you for that, Max. Yeah, I misunderstood the question. Any 3 consecutive months. Okay. All right. That kind of blows a hole in my entire thing. So Raton was fine in these 3 months, but was not fine in these 3 months. So we need the math that I did for Tamal was fine. For Raton, these 3 months were actually fine. They were more than minus 20. So x is actually more than 10, and we don't gain any information from this Tamal thing now. But from Raton, there is another 3-month period to be concerned about, which is here. A chicken tamal? Tamales are great. So that was a bad 3 months. So that's less than minus 20. Thank you for the save, Max. 35, so 15. Okay, and we know x has to be even. Yeah, good shout there, Ayush. There's also another 3-month block right here that we can check out too. So yeah, let's check all these just to make sure we know all the conditions. I bet we've already narrowed it down though. For this Tamal block, it was a good block. So x minus 20 plus 5 is more than minus 20. X is more than minus 5. That doesn't help. But let's check Upanshu. The moon for movie chat. What should I watch? Have you seen the new Dune movies? Like, I mean, the last like few years. I watched those recently and I really liked them. Let's check. This was a good block. Nope. Then that's my recommendation. They are pretty long, but I thought they were really good. You're allergic to sand? Achoo? Well, that's not my problem. Negative x is more than equal to minus 10. X is less than or equal to 10. Oh. Okay, yeah, Ayush, good call. I'm trying to think of what else. It's a horror movie, but I watched Ready or Not recently too, and that's a fun movie. It's not like amazing, but it's fun. Hey, Papadoria. Max, that's kind of a weird one. I'm interpreting that as from this state from number 2 in the notes, the value in any cell is an integer, and there's x over 2 in one of the cells. Hey, Dwarf Keck. Nice to not have the problems of other people. Yeah, that's a nice thing. I heard from a YouTube video a high school math teacher fired for multiplying 2 different inequalities. Ooh. I think you can sometimes do that, right? But not usually. Oh, people are talking about Project Hail Mary is on my list for sure. It's supposed to be a good one. Barry London? I never heard of that. Yeah, it's definitely a tedious problem. I think we can answer the first part though. The strictest rules we have are more than 0 and less than 10. Oh wait. So it still is option A, ironically. I got it for the wrong reasons though. X equals 10? Is it? How do we know equals 10? Why can't 2, 4, 6, or 8 work? A K-drama? Hey, if that's what you want to watch, no judgment. From Ratan and Upanshu. Oh, ha! I misread this inequality. I was still on the old one for Raton. Okay. Yep, x equals 10. And that's convenient because we get to fill that in on the table now. Why circle the entire thing? Okay. So yeah, God, this is a lot to keep track of. So 10, 10, 5, 10, minus 10. There we go. I mean, I don't think this problem is exciting either, Dessen. Okay. The value for y. We have a couple of 3-month blocks that we can work with and a 6-month block. 2 6-month blocks, I guess. From Shri. Also, a bunch of information from Tamal. Oh my god, this is so much work. Yeah, this is one that you could program. Okay, Dev. I've shown the process for X. The process for Y is going to be the same. I don't have the willpower to do this, though. I'm sorry. This problem is, I think, too tedious for me. And I'd like to do other things. If you have a question about how exactly to do something, you can ask it, but I'm not just going to solve the problem. I'm not going to solve the entire problem for you here. This is, I think this is too much. Side hustle has an accountant? Maybe. The weird functional equation problem if you guys want. The mathematics Olympiad local to my college have written a bunch of problems. I probably will do it, but yeah, let's see it, Papadoria. You always have good luck in your personal affairs. I hope it's not a lie. Yeah, I hope so too for you, Dwarfkek. Is it time for PDEs? It's time for Papadoria functional equation, I guess. Sorry if you're hyped for PDEs. Yeah, sorry, Dev, that you have to do problems like this. It's tedious and it doesn't teach you all that much. I wish you weren't being asked questions like that. We are waiting to hear from Papadoria, so we can do a little bit of PDs in the meantime. As PED? As geometric PDs? I assume that you mean a certain thing with that I don't know. You can definitely interpret a PD geometrically. Okay, yeah, Carl Cohn is better to answer that. Geometric analysis. Can we take the gradient of this Taylor series? Well, I guess we should plug in QX. Well, no, I guess... Do we plug in Q first or after? I guess we need both for X and for... Well, I don't know. Yeah, it's a Hessian. From what Carl Cohn was saying the other day, it's actually a helpful thing based on the properties of the Hessian, but we haven't talked about very much in this PDEs class. It's not very... The professor, he's a really funny dude, and I like him as a person, but he said he's never taught the class before, and he does not have a plan for what he's going to teach or how. So it's kind of it's going to be an interesting one. You and that should have some beef. Oh, I'm interested to hear. Might be too much to explain in Twitch chat, but oh, Papadoria posted. I'm gonna take a screenshot of this Discord message. Uh, if they don't get killed every 5 seconds, I'll just wait till I get a chance to work on the PD homework properly. That I'm gonna feel like I'm dying every 5 seconds. Also, when I was playing yesterday, I actually had a really good fight. I did end up dying, but I went out swinging. Not much of a story here, just a particular problem I was working on. We reduced it down to compute the Hessian, then failed to do that for about 6 months before we gave up. Oh god. It's a hell of a Hessian. X iterations of it on X makes it X plus 1. I assume it was like not for, I assume it was for like some general type of a function or something. Not just straight up thing you could plug into Wolfram Alpha. The discontinuous case is trivial. What is C0? Is C0 like piecewise differentiable? I don't remember. It just means continuous? Okay. So the discontinuous... I'm, uh... I don't know why I can't even figure the I kind of no I don't know why I can't figure the discontinuous. I should just look at the spoiler. Um, first n-1 derivatives. Okay, yeah. Oh, this is just I should use your playlist more. I've lost the link to it, but this is just a Spotify radio station for a song. I'm looking at the spoiler. X plus 1 over floor X. I was thinking of the floor function. I couldn't make it work though. Why does that give us what we want? Yep, I would say like I apparently have a very difficult time thinking of function composition because this is not making sense to me at all. I would need to spend a lot of time like playing with this to understand it, I think. Thank you for trying with me, but I do think it's PDE time. Max is saying we want x steps until x plus 1, so we add 1 over x each time. I'm sorry, I still don't get it, Max. It doesn't make sense to me. It is posted in the Discord if anyone wants to like take a whack at it, or you can put your thoughts in the Twitch chat too. But I'm just immediately stumped with that problem, unfortunately. So as you compute these inner products, yeah, it's not trivial to me at least. But for the math that Papadoria does, that'd be considered trivial. The delta, in this context, delta is the Laplacian. I don't like it. I prefer nabla squared. But I'm not the one who wrote the question. Okay, so I was confused on this when the professor wrote this during the lecture, but I believe this is just an inner product. The confusing bit is that if this is suddenly a matrix, actually it's still a vector. Uh, these two things should be the same. Does the order matter for this? I I'm kind of so like d squared is a matrix. And I don't the inner product of a vector with a matrix, I guess looks like that. These two things are vectors. What's orthogonal matrix? I know you know what an orthogonal matrix is, right? Or are you actually asking? Are you trying to like give me a hint there, or you're asking what the definition of an orthogonal matrix actually is? Yeah, for people who are doing Olympiad math, I think it's fair to call that trivial. Beginner stuff. This is for advanced methods for partial differential equations. And if you don't know what that means, let me know and I can explain it to you. Yeah, methods for or advanced methods for partial differential equations is the name of the class. Okay, so my hope with doing this is that we can actually compute the Laplacian of this. Of both of these things here. You took ODs, you know nothing about solving PDEs. Yeah, so that's good then. Yeah, if you know ODs, that's a good like background to think about PDEs. This is not how I would introduce PDEs to someone. um, we've been in this class, so the class only just started. We've been talking about kind of the first PDE that you typically learn about, which is called Laplace's equation. Depending on your notation, you might call it delta U or you might call it nabla squared U. Um, and sorry, the U is a function. I'm just gonna say of x and y. It can be of any number of variables, but I'll just do two dimensions here. And the Laplacian operator is second partial derivatives added together. So all of these three things are the same thing, and you set them equal to 0. And it's a really cool equation. It's really fundamental, and a lot of things kind of can be modeled by this. And it's a bunch of really nice properties too. And yeah, so we haven't even talked about linear algebra in this class, to be honest. It's always kind of in the background because it is a linear equation. And linear algebra is even in the background of ODEs if you have a linear differential equation. That's where the word linear comes from there. Yeah, we've never talked about doing a change of variables that looks like this, so I'm kind of lost on that part. I'm throwing spaghetti at the wall and doing a Taylor series in multiple variables. And hoping that this helps solve the problem. I don't know that it actually will. I can't tell if you're messing with me, Destin, or what you're doing here. But I was talking about linear differential equations. And linear is the same linear that they refer to in linear algebra. Like the same like definition, I guess. Are linear then? Sure. Okay, so surely the Laplacian of a constant is 0. Surely the Laplacian of a linear function is also 0. I hope I'm not glazing over something. Um, the Laplacian of this, I don't frickin' know. U and V are like 1 by n vectors. They are scalars. U in V map Rn to R. Wait, yes. Why not differentiate each entry? Is that how differentiation works? I honestly, I couldn't tell you how to differentiate a vector or a matrix. If it's element wise, that's probably good news. How comfortable should you be with ODs before learning how to solve the most basic PDE? You don't need to be that comfortable. If you can solve like a first order ODE with an integrating factor, and if you can solve a second order ODE with constant coefficients, I think you can solve the most basic PDE. And so the one that I was kind of introduced to first is a slightly harder version of Laplace's equation, which is the Laplacian. It's called, actually, let me tell you the name of it first. The heat equation. This technique would probably also work for Laplace's equation. I just haven't tried it. But let me write the equation first. Delta U is equal to UT. And make it one variable just to make life simpler. So U is going to be a function of x and time. So second derivative of U in x is equal to the first derivative of U in t. You know how to solve an ODE. If you see the solution, you'll remember it. Fair enough. I aside for severable. You do those, so nice. Yeah. Awesome. Sometimes you put a constant in front. It's probably best practice to do that. Just some constant k. And so how you proceed from here is you do something called separation of variables. It's not the same separation of variables that you would know about, though. Same name, different thing. I assume, at least. There might be some weird connection that I don't know of, but in this context, I'm talking about you assume that U of x, that your solution U is of the form some function involving only x times some other function involving only time. It's the product of two functions. There's a reason why this assumption is a good one to make. It's very deep math that I don't know for myself, though. And so I'm not going to go through the entire thing, but at least like do the first stage here, which is if we're assuming this for our u, we can compute the second partial in x, the first partial in time, and plug it in. So, Colin, when I said that, I've heard Zach say this is because of orthogonality. So using this definition, do the second partial in x. We don't necessarily know, like, let me write this out. It's kind of a weird looking partial to compute. The function in time is basically just a coefficient. It doesn't matter. It can be taken outside of the derivative entirely. And so I'm just going to call it x double prime times t. Oh, really, Colorcone? All right. I mean, that's just me repeating something that I've heard. I couldn't tell you for myself. I guess only a solution, Max. I was just doing this as a demonstration to show like how knowledge of ODEs builds into solving PDEs. This is the first example that I thought of, or like the simplest one. So same thing here. The function in x could come out front. X, big X, small x. And I'm going to say t prime. I'm using the prime notation here is a little bit sloppy because this double prime is with x and this prime here is with t. But you get it though? Okay, perfect. So then plug these two things in to this equation here. We get x double prime x t of t is equal to k x of x t prime t. And then get all the x's on one side, get all the t's on the other side. So x double prime over x divided by x of x is equal to k t prime of t over t of t. So now we need to think about this intuitively. If we have something involving x's on one side and something involving t's on the other side, and they're equal, there must be a bunch of cancellations. It would make no sense to have the equation like sine of x is equal to ln of t. This doesn't really like... I mean, you could call that a function, but like... this bit is a little bit hard to explain, but... yeah, this is how I think about it in my head, but not when I say it out loud, it doesn't make as much sense as I thought it did. What I'm trying to say is that in order for this equality to be true, we want there to be a bunch of cancellations so that it's just a constant on each side. So I'm going to call it alpha. I think I'm doing this right. I don't... My explanation for this isn't as good as I thought it was. I have to think about it more for why we're allowed to say that, but we're basically forcing there to all the x's to cancel on this side and all the t's to cancel on this side. And what we get now is two different equations, only in x and one in x and one in t. X double prime over x is equal to alpha, and k t prime t over t of t is equal to alpha. And now these are two separate ODEs that you can solve with your usual methods. It is important. K is a positive number. Alpha might be able to be anything. It probably is. And so what you do is you would find the function for x, find the function for t, and then you just come back to your original assumption and combine them, and that's your answer. You should get, the time should be an exponential decay function, and the x function should be sines and cosines. And so what it ends up being is like a function that oscillates, but the oscillations go to 0. If you do that for solving a similar problem, the unit disk separation of variables using Cartesian coordinates. Oh, fair enough. That's a good point, color cone. Wouldn't the equation look different in other coordinates, though? Like, we'd have a different Laplacian. Okay. So yeah, that's kind of like, I think it's the first thing that's the first PDE I ever learned to solve, and that's how I learned to solve it. There are a few other things about PDEs that are important. Yeah, Murder, you get like some you get a lot of strange looking factors in other coordinates, like with r's and sine theta and stuff. Yeah, I'm sure if you search heat equation separation of variables, you could find a proper like explanation of this. The heat equation is super cool in general, though. Like what it describes physically is let's just pretend you have like a square room, and magically you keep this wall at, say, I don't know, 50 degrees, this wall at 70. I should maybe do something a little more symmetric so it's cleaner. Let's do 50, 50, 70, and 70. And the room at time 0 initially starts with some distribution. Like maybe there's like a hot spot in the middle, and then a cold spot, or like a colder spot outside of it, and then even colder on the outside. What the heat equation tells you is how the heat in this room would change over time given this setup. So like I would expect this bump in the middle to flatten out, basically, and over time it should evolve. It 50, 50, 70, 70. Over time, it should evolve to look something like I would guess the solution is gonna look kind of like this. You have hotspots by the walls that are 70. And then kind of cooler, like just warm spots in the middle here. And then when I say cold, I mean just 50 degrees or so in these spots here. This is kind of a guess, but it's something like that, where like if you just like let it go, like the spots by the 70-degree walls should become 70 degrees. The spots by the 50 degrees wall should become 50 degrees. And then it kind of smoothly transitions between those two regions. That's what I'm trying to like show here. And this isn't just heat either. This can describe other things that kind of distribute or diffuse. It's diffuse might be the wrong word. I no, yeah, it is diffuse. It's sometimes called the diffusion equation instead of the heat equation because it doesn't describe just heat, but heat is a nice way to think about it. Exactly that. If you tell me a position in the room and a time to measure it at, I can tell you the temperature if I'm you. That's a confusing sentence. If I'm you, if I am the function you, that's what I would do. Perfect. Yeah. For this like drawing I've done here. Oh yeah, I did accidentally do a two-dimensional drawing, and I was only doing one dimension up here. Um, you see, yeah, you're gonna do right. It'd be u of x, y, and t. Yeah. I think this stuff is really amazing. It like PDs get at the heart of like just kind of how the universe works, I think. Um, and there's been like especially in like physics, like in physics classes, I've realized that we've been secretly doing PDEs without even like, but the PDEs were like hidden away from you because you hadn't like learned about them yet. Yeah, that I think they're super cool things. Okay, so yeah, I'll give a little explanation of like the basics of PDs there. But if you want to ask any further questions, like please do. Figured out an easy way to get the change of variable for the Hessian for the linear change of variable. Ooh, yeah. Please share color cone. I don't really know what I'm doing with my Taylor series thing here. Gives you quick satisfaction with not much wall of machinery. PDEs do, Dessen, or I think they can. I feel like PDEs have a bunch of machinery though. If you go looking for it. Yes, PDEs. Okay. F of A. And so could you just multiply those? Is F of A the same as A times F? Or not necessarily if F isn't linear? That's probably where color cone is going with this, Dessen. Because color cone figured out this problem the last time I streamed math, but it was using something that I hadn't seen before. So color cone's explaining uh change the variables for Hessians. should be A transpose. Let's delete this. Hopefully I don't regret doing that later. So wait, is the A sub P inside of the gradient? I guess that's not the way that you've written it. Or is it like... Evaluate the gradient out? Oh, okay, okay. So, I don't know the best way to write this. I guess maybe this is hopefully the least confusing. I don't know. Left side should also be evaluated at P. Okay. JF of JA. No? I don't remember how you take derivatives of vectors. I don't know if I've even done this before. I don't know where either of these equalities come from. No, I don't know where either equation comes from. Okay, I'll raise you and ask you what the Jacobian is, because I've done Jacobians before. I can never remember what kind of matrix they actually are. I know they're like the factor you need when you do changes of variables. Okay, the matrix are the first derivatives. Okay. So it's the product. Okay, so this composition becomes matrix multiplication then on the right side? Yes, okay. Okay, yes. I can believe that's chain rule then. It's one by n entries. That makes sense because we have n inputs but only one output. It's a nice song. Oh, I added it to the wrong playlist. Sorry, I'm getting distracted. I'm back. um, well, as Destin said, it's a one or oh yeah, that's also a 1 by n vector. Same with the composition. But like, yeah, these are both one by n vectors. I think that will make this n by n. How would the gradient be related to j of f? Oh, that is just the gradient. Holy crap. Really? 1 by n. Oh, the transpose. Oh, the gradient is n by 1 by default? Okay. So we could write that. And this is starting to look like the transpose of this, is the point? The Jacobian of A. Do a toy example. Oh, I think I can see why it's going to turn out to be just A if A is a linear function. Yeah. It would still help me to write this out. But this is making sense. It would be A, B, C. I don't know my alphabet. D. Okay. So right. You write it the same way that you wrote it? Taking the transpose of each side will give us the above equation. Okay. So taking this left side, I could say it's equal to the transpose of J. I don't know. I feel like the T should be over here, but that doesn't feel right. I don't know. Probably too many parentheses, but it makes me happy. Okay. Um, so what was the Where the differentiate one more time. I think color cone's idea was to say that the Laplacian of u is equal to the trace of the Hessian of u. Um, SF is equal to J of grad F. The Jacobian of the gradient. I think no, I that makes sense. I can see how that would give you all the every combination of the second derivatives by taking the Jacobian of the gradient. Okay, yeah, yeah. Oh, okay. Slap the Jacobian on each side of the first equation. Just slap it. Slap the base. Davey 5. I don't know who that is. The left side is Hessian of f of a. That would make sense. I assume we're still evaluated at P, and that would stay on the inside of the Hessian. Well, the Hessian of a... maybe the evaluation should come outside. Well, wait. I don't know. It shouldn't come outside, but... actually, in this step, why doesn't... If we're evaluating it at a point, wouldn't the Jacobian just become 0? If we've already evaluated the function at a point? Should we not evaluate it at a point yet when we do this? Okay. Okay. Clunk. Wait, what? I don't... What fortune is that? Is that... I also don't know... That... I'm worried that I should remove that fortune. I'm gonna Google what that disease is. Is that a real disease? Okay, I think there's a better word for it. That is the name of a pandemic. It gives you luck. Let's hope so. Probably better to call it 1957 influenza pandemic or whatever actual type of thing it is, though. I'm gonna make a reminder to remove that fortune. I'm not a fan of that one. Oh, hope you're doing well though, Clunk. Okay. Um, hey girl that is small. And hey Tiamak, are you a turtle? Avocado tone refrigerator look these are terrible fortunes. I don't know why these all suck. Your mode of life will be changed for the better because of new developments. That's a nice one at least. I missed the one that Destin opened. You would say yes? Fair enough. You turtle it up. Yeah, I'm sorry, Carl. Let me. The right side is the composition of the form A transpose grad F. A transpose grad F. I'm trying to figure out why that's true. A of P? I'm nowhere close to done with my homework, Destin. Your weekend starts right now? Congratulations. That's awesome. It's better to ask some questions than to know all the answers. That's a good fortune. She has some unfortunate cookies. There are some unfortunate ones in there. Um. Oh, okay. So we're trading evaluation at a point for matrix multiplication, which is the same thing. Uh. Composition. Okay. There's probably an important difference there. That's not just necessarily matrix multiplication, because F isn't necessarily linear or grad F. We're taking the Jacobian on this thing and using the chain rule on it. So it's going to end up having this form. Uh, A transpose. Right, yeah. Uh, J of grad f? Oh, right. Thank you. What band is this? TV girl. Okay. We have Hess f of a is equal to a transpose. Oh, wow. Holy crap. That snuck up on me. Okay, yeah, that is the exact result that you were saying we wanted. Holy crap. Okay. Thank you for your patience with me there. So we have the result that we need. And if I remember your argument correctly, once we do have that result, curl out a smell, no worries at all. Come and go as much as you like. Or as much as, yeah, as much as you like. I appreciate anything that's more than 0. It does look like a conjugation, yeah. There's actually, it probably, there, you probably interpret that as a conjugation in some way. I would bet. Are Hessians, they are symmetric, right? So it is literally a transpose. I guess they might not be symmetric if there's, well, yeah. As long as the partial derivatives, you can interchange the order. For a C2 function, right, yeah. Oh, so does this prove it for all x, or did I need to plug in 0 at some point? Maybe it is just true for all x. Hmm. Q of x maps x as something other than x. Q is linear, so we only know Q of 0 is 0. Oh, so maybe there's like a change of, like, okay, so, I mean, I wonder if there is a small error in what I wrote here, because I did start with v of x is equal to u of q of x, but like this x isn't necessarily the same as this x. So your mom can let you play with us in the park. That's why I guess that's why I was wondering if I needed to plug in 0 at some point. Why do I have 7 pings from the same Discord server? should just leave this Discord server, dude. They freaking spam ping way too much. Anyway, by saying linear from the beginning, it proves that that would, yeah, you know, fuck all this work, just linear. Turn that in. I like it, and don't even bother like writing it legibly either. Okay. I still want to investigate the Taylor series idea at some point, but this is like probably a much nicer argument, color cone. So thank you for walking me through both like how to justify the properties and the actual like argument itself. I think I'm gonna leave question 2 there for now. Carlcone did also show for an arbitrary isometry, whatever that is. Okay, yeah, that to doing Taylor series be more in line with like what we're talking about in class. I need to get better with like multivariable calculus though. This because I'm very lost with all these things that color cone was just doing. I wouldn't have been able to do it myself. A math that preserves distance. Okay. We could try and write up. So color cone also figured this problem out. We could try and write this up, or we could just go on to a new problem. I kind of want to do a new problem. Start thinking about subharmonic functions. So how do we prove the maximum principle? It's a good point to see the Laplacian is a sensible way we measure distance. It is? I don't... The Laplacian measures distance. I didn't know that. Hey, Slim. Not what you meant? It's sensible to the way we measure distance. I'm not sure that sensible is the right word then, or I don't understand this, the sentence. Okay, this is unfortunate. So we were talking about harmonic functions with a probability bent. Okay, let's start at the maximum principle for harmonic functions. Change of coordinates that aren't given by an isometry, the Laplacian will change a lot. Right. Or I can believe that at least. Oh, it's sensitive to the way we measure distance. Okay. Yeah. That that makes sense with the word sensitive instead. X in the closure of some domain. is equal to the max on the boundary. There's a typo in my notes. I don't think we need the second part. The second part is that if the maximum is attained inside the domain, then u is a constant. I'm not going to care about that. If we change the way distances are measured, we might be getting something else. Fair enough. You got a cold, you're finally getting over it? Hopefully stream again soon. The world needs more slum streams. So the way we prove this in class, or I guess it's a proof, yeah. We use the mean value. Is this mean value? What is this? I don't think it's mean value. Yeah. I don't know what he started using measure theory, and he even asked if it's a prerequisite for the class. We told him it's not, and he was using measure theory and just trying to like explain it intuitively. I only can guess what I have intuition for what this means. I don't know what it actually means. He did say this is okay, well let me okay. There exists a probability measure mu sub x supported on the boundary. And this is the equation that comes from that statement, apparently. The geometric definition of Laplacian would have made this exercise trivial. Oh, really? Measure theory is difficult for me? I'd like to learn it. I don't think I'd be good at it, though. Okay, so I think this is using the mean value property for harmonic functions on the boundary. It's just expressing the integral in a different way. That is presumably equivalent. And so the way that we prove this in class was to start with this statement. And I do have a note that this mu sub x of y is a harmonic measure with a pole at x, whatever that means. You can bound this bad boy above a finite domain omega. I mean, that's what we did in this proof. But omega is arbitrary, but like it's smooth. It's nice enough to not cause issues. That's a terrible omega. mu sub x of y. So we're taking g and replacing it with its maximum value on the boundary, and that's just a constant. We are assuming the boundary itself is bounded, and the function g, that is the boundary data, is also bounded. If the domain is infinite, I assume you don't have the boundary part of the mean value property. That wouldn't make much sense. Well, it might make sense if it decays at the boundary. Actually, that could make sense. Even if it doesn't decay at the boundary, that's just a constant function. We definitely said that G is bounded. Probability measure base equivalent to omega has norm 1. Yeah, that's the fact that we're about to use it in the next step. Because this maximum is just a constant, so it can come outside of the integral. And then the integral that remains is just 1. So that's a proof that we did for regular harmonic functions. So G is bounded. I'll promise you that much. The boundary could be empty. As an open? If there is MMP for harmonics, Bargman, Lindelof also exist? Oh, I couldn't tell you that. Wait. Okay, never mind. Never mind. So do we still have the mean value property for subharmonic functions? Oh, that's your concern? That's a good question, Color Cone. It shouldn't. Maybe this doesn't use the mean value property then. That's a really good question. I wish I thought to ask that during class. Because we justified this probability statement in an intuitive way. So he didn't technically use the mean value property. Like, he didn't say it outright, and we really couldn't use it for an arbitrary domain. Um, the hard way to always think geometrically. Yeah, it's fair enough. I don't know what a subharmonic function would look like geometrically. So, okay, the way that we justified it is let's make an arbitrary domain. If you choose a point of interest here that you want to know the value of, what you can do is I don't quite know why this is the algorithm exactly, but draw the largest radius you possibly can that fits inside of the boundary. Randomly, uniformly choose a new point on this boundary. Say it goes there. Let me draw it a little bit closer. And repeat the process. I should also say, let's say the value on this section is 10. The value on this section is 5. And then the value on this section is 3 for boundary values. You stop doing this process when you happen to get a point that is sufficiently close to the boundary for some tolerance. And you take that boundary value that you're close to as the value for x. So in this case, we got 10. And then you repeat the process an arbitrary number of times. So in other cases, you'll get 5. In other cases, you'll get 3. And the expected value of doing this process over and over again is the true value of u at that point. That's how he justified this statement. You don't need to prove the other inequality right because it's trivial. Oh, this one here? Yeah, we would call that one trivial. Talk about the stock at intersection? About sections? I don't know exactly what that means. Let me get the music playing again. See, I at the time we were learning this, I thought this was mean value property. But it's not, I think. G is the boundary condition. So if U is subharmonic, it is at least harmonic. Or like, that's a stupid statement to make. But we know it's bounded below. A subharmonic function is bounded below by some harmonic function. Oh, wait. Wait, how? Wait. Uh, what's my, how do we get the other equality? This, we didn't actually prove the maximum value principle. What is this crap? Oh, damn it. Wait, yeah, all this argument here shows is that u of x is less than or equal to the maximum on the boundary. It doesn't show the one for inside the boundary, though. Um, yeah, I might have misunderstood what Desmond was asking about before. For the problem, the first equality should be less than or equal to? I think you did. The other side is trivial, as Desmond said. Oh, I don't see it. At least not right now, though. Um, X is in bar omega, presumably? Uh, oh, okay. We proved this for all X. Okay, okay, okay. Okay, good. Good, 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 good. Oh. Find the maximum in a smaller region. Like the boundary has to be smaller than the maximum in the whole region. Yeah. Okay, I... That's one crisis averted. You're saying for the problem, the first equality should be less, like this equality here should be less than or equal to? Or am I misunderstanding what you said earlier, Slim? You can do that with the boundary being included in bar omega. Okay. The proof you did works for harmonic, and for subharmonic, only change that first equality to inequality. Oh, that seems reasonable, right? Uh, he did say there's an entirely different proof in the book that doesn't appeal to probability. This was like the simple version of the proof that he gave to us, but the reason that we use probability is to justify it for an arbitrary domain. If we use dx, we'd be stuck with the maximum value principle, and that only applies to spherical boundaries. So if the Laplacian is more than 0, right, okay, that makes sense why this is less than or equal to. Thinking about the mean value property, at least. Or in terms of the mean value property. And I guess that would probably extend to this, it would hopefully extend to this probability argument too. Huh. I wonder if that's a typo then. I'm going to check my email and also check the course website. Or no. Files. When is this homework due, by the way? April 9th. 5 days. Okay, if it is a typo, it hasn't been corrected yet, at least. Actually, the internet should have an answer to this question, right? Subharmonic function. Is there a Wikipedia page for this? Down half a bottle of vodka, but it's chill because I can still do my topology homework? Okay. Drink water syntax. Enjoy, though. I like to understand the first equality better. I think if I understand that equality, I'd be content with that proof. Yeah, like he was just giving us like the intuition for why this should be true. He definitely did not write an actual proof for this. Um uh I I bet there is a nice way to write this up. I couldn't tell you how though. No, this is from PDEs syntax. We're talking about solutions of Laplace's equation on an arbitrary domain. And there's some kind of interesting probability stuff that we're doing with that, and measure theory stuff that comes in there too. Oh, I mean, that's not a bad guess when you see. I mean, was the overline? I don't know where the B was, but I definitely have a capital omega in there. Or let's wait. I don't know. Oh, you mean here? Oh my god. Sorry. Control F sub. Nope. Hmm. They didn't write it out explicitly, unfortunately. Well, we can look at other things. Subharmonic function, maximum principal. I don't know. I'm getting bored of thinking. I'm gonna be honest. Ugh. I probably shouldn't stream for much longer, but I'm not bored of thinking, but like tired of thinking. Um, not a few weeks, but a few months. Um, On Thursday, I put in my request to graduate. And as long as I don't like completely fail my classes this quarter, I'll graduate in mid-June. A few years? I sure hope not. Vodka time? Oh, for you, yeah. But let's at least look at number 5. I'm definitely getting mentally tired though. See if we can get an idea for it at least though. Oh, you figured out syntax? That's good. So I definitely was not going to. um, once I graduate, um, the plan is to apply for jobs. I don't know how it's gonna go, but that's my plan. I don't know what kind of job though. I haven't gotten that far. Spam compliments to get the definition of continuous via open sets. Fair enough. What norm is this? I would guess Euclidean. Whatever the nicest norm is. Dating a math major be like? Oh, that's a good one. Been training my mercenary skills. Yeah. If you wanted to get into the mercenary business, where do you go? It's a good question. There needs to be some type of like John Wick hotel in real life. There should be an app for that. That's starting to sound like an episode of a TV show that I've seen. I don't remember what it was though. It's getting a hitman off an app. Maybe it was Barry. I don't remember. I think the joke was about just about the spamming compliments part. I don't know. Dating app only for math majors? Sounds like it'd be 99% dudes. Um, become a quant like Slim. Is Slim actually a quant? I don't think I'd want to be a quant. Right, military service mate said he had a bunkmate who said he wanted to go to a war. Oh, I guess he's getting what he's asking for. Potentially. Many ways of making money with a math degree. People need math and actuary. I wouldn't want to be an actuary. Um, yeah, I don't know. At some point soon, I've got to think about what type of job I actually want. Go to the nearest unemployment center. You were a quant once. Oh, that's interesting. Got swipe left on the analyst. I dated a math girl. What area to like her to be in? In my area, if you know what I mean. Hey yo. Um, I don't think I'd mind any area. I guess it's nice if you have a common interest in like the actual type of math, but I wouldn't be like, oh, you like number theory? Never mind. Do you need campaign around being an actuary? Sounds like a very. I mean, maybe you could make that interesting. I don't know how though. Do we just take the Laplacian of this? Uh, how does this Laplacian work? So this is a function of all n variables. So whatever variable matches will have a special uh uh word. It'll have a special form. So we need to do a chain rule type of thing. God, I can't do this right now. This term is going to become, I think, n many terms is what I'm trying to do. Uh, catch up with chat. Basic character on ourselves. Math jobs are sometimes random posts for companies needing applied math people. I didn't know there's a math jobs website. Shouldn't finance math as a red flag? Honestly, finance or AI could be a red flag depending on the person. Like depending on why they like it. Those posts don't appear very often. Okay. Hey, Fembucks. Always uh loving number theory. My small brain was thinking just take the Laplacian. Yeah, maybe there's a better way, but with small brain together strong. Beauty, mate. I think of like kind of like the tech bro, the person who wants to be a tech bro or a tech cis, I guess, if that's a word. And you are the red flag. Yeah, I don't think it has to be red flag. Just why they're interested in AI could be a red flag. Um, what is the partial derivative of this function with respect to x2? I don't think we can unpack that in any way. Like, I think we have to leave it as is, don't we? I don't think we can do anything with that. You think that's false? Enlighten me. uh, Firms getting more involved with AI and lean. I mean that's not a bad thing. You mean tech? Yeah. Uh, I mean, yeah. In Warren Berman, California is the Silicon Valley, so there's quite a few tech bros there too. I don't know. I I've been trying. I've been trying not to think about what kind of job I want because it's a source of stress for me. But I do kind of have to. Okay, color code is saying if u of x equals sine x. Well, wait, are you saying this is the false one? Or wait. Oh my, I'm doing first derivative. Ugh. I need to do two derivatives, not just one. I do not have a handshake account. Wait, so you're saying that the actual prompt is wrong? I should have maybe looked for counterexamples first, because it is prove or disprove. I just read it as prove. So sine of x, it is harmonic. We can agree on that. Okay, and so I guess u is equal to sine x. Grad u is cosine x. V is equal to cosine squared. The Laplacian of v is in your Wolfram alpha link. 2 sine squared minus 2 cosine squared. And the claim is this is subharmonic. Or we need to look at the graph, which Wolfram alpha provides us. Oh, well, there you have it. It's sometimes positive, sometimes negative. So it can be subharmonic. Okay, well, color cone, you rescue me from doing the chain rule n squared many times. So thank you. From the problem? I don't know. I mean, the assignments are posted to Canvas, but oh yeah, like it's an actual homework assignment for my class. That was, and the assignment was posted on Canvas, if that's what you mean. Okay. Um, that's probably a good place to wrap it up then. Oh wait, Fembox, if you're still here, um, I wanted to talk to you about what I learned in my PDE class yesterday because I thought it was really cool and it was related to what we've been talking about or what we've like studied before. Uh, the norm, and well, it's just a one-dimensional variable, so we just end up squaring it. Or like we're letting n be 1 here, if that's what you mean, Dessen. I might be misunderstanding you though. Oh my god, I can't even find this book. Uh, oh. Stooky, you raise a solid point. I think I definitely got mixed up with thinking sin of x is harmonic from a previous problem. This is not harmonic. I got mixed up. I assume color cone made the same mistake. From this problem earlier, we had to find a function that satisfies this. Yeah, the eigenfunction of the Laplacian. And that was sine and or cosine. Alright, Laplacian n squared times. I shouldn't have deleted that work. Shoot. Oh wait. If I undo hard enough. Oh! Well, we don't need that. I mean, this is still wrong. I was doing first derivatives here. Yeah, you. I mean, thank you, because you're correct. That is a lot more work now, though. I mean, we could keep looking for counterexamples. What's a simple harmonic function? Linear functions? I doubt linear function is gonna be a counterexample. No, I think linear functions are fine. Spent 6 months for the Hessian. Yeah. Oh wait, actually, I guess the good news for second derivatives is these other ones just get second derivatives. The only thing that changes is the first derivative, right? I just need to take one more derivative with x1. Treacherous kung fu math. That's a product rule. So we take the derivative of that, it becomes a second derivative, but then it's multiplied by that, so we just square. Plus 2. Ooh, we're gonna get a third derivative. This is jerk or snap or bend or whatever. Snap, crackle, pop. Jerkin, yep. Jerkin time. Jerkin time. Time. I don't know the rest of the lyrics to that song. I'm hoping for cancellations, or that nothing is necessarily going to cancel. Well, we need it to cancel. If V, or, well, not necessarily cancel. We need a positive number. Or 0. I see the trick here, but it's too funny not to say. Gay boners 42. Thank you for the follow. Dear friend of mine, gay boners. Did you do a math D&D campaign? Oh, is that what the video's about? Okay, let's do one more line for x2. Wait. Wait a minute. It's 2d. Yeah. Okay. Ugh. Seeing that when we were talking about some work in finance. Okay. What do we do with this? Okay, so we know that U is harmonic. Is there a Laplacian of U hidden anywhere inside of this? There's a Laplacian of grad U. Well, that's where we came from. Well, no, that's not where we came from. We came from uh the the something. Um, Wait. Is there a Laplacian of U in here? Or a Laplacian of grad U, rather? Ugh. Have to be applied to the whole thing. Uh, what whole thing? Like, if you mean like the squared is inside of the derivatives, if you're talking about that part. Too afraid of whips and chains. I don't quite see a little Laplacian of U or even grad U in here. Rihanna does have a whole song about that. Sticks and stones may break her bones, but chains and whips excite her. Maybe to start the computation. I'm basically doing. I'm doing the caveman thing. I took the Laplacian of this expression here, and so each of these terms gets its own Laplacian. And there's a special case when the derivatives match up. You need to do the chain rule. But other than that, I don't think you can simplify the other ones. I don't know. I'm not above just sleeping on this problem. I bet the answer is somewhere inside of here. It's just the only thing we need to show is that this is a positive number. That's a little easier said than done, I think, but that's what that's the goal here. I wonder if we can make a statement about the Laplacian. Oh, like I'm thinking like these terms. Are this just missing the first term? I don't think we can do anything with that. I don't know. You're taking a pen? Color cone is locking in. I don't know. It is awful tempting to group these terms. What would these terms be? They would be the norm? Well, is there like a gradient for second derivatives? I guess it's like the trace of the Hessian. Again, or something? I don't know. No, it's not the trace. Instead of adding them, you make a vector out of them. 2 grad students and 2 Yeah, it doesn't. I'm not gonna lie. It's really nice to be a streamer and have like color cone and people like him like helping me out with my homework. And see, doesn't next time you're stuck on a problem, just think of that as incentive to become a streamer. I feel like this is nothing, and I should look for a more elegant way of doing this proof. Maybe it's just my tired brain here, though. Isn't v of x always 0? Is it? Uh, if the statement is correct, it should be positive or 0. It might not be correct. Like, we could keep looking for counterexamples. You know, maybe I should just go back to the sine of x counterexample. That was much nicer. Quote unquote counterexample. Like uij squared plus uijj. Ooh. I don't get a no. I don't get a mixed third partial. It's because I'm taking derivatives of the squares is the issue. I don't have any mixed partials. I didn't feel like it was possible to take any. Partial j. Wait. Okay, I was about to be like, where does I come into the picture? Partial j u sub I. Oh my god. I'm mixing my notation here. Wait, you can chain rule this? I thought you just couldn't simplify it. Um, how does chain rule work on this? Um, the thing inside here, it is a function of x sub j. Is that the point? Among other things? UI. Oh, okay. Well, maybe we are getting somewhere then. I think, yeah, I should probably not do the curly Ds anymore for this problem. They're kind of cumbersome. Right, because we need second derivatives. Okay. Um, yeah, unfortunately. We're taking another derivative with respect to J. So this is a product rule. 2u, that's not I, uij, oh, squared, plus 2u, okay, and that's the term that you got. That's the thing that you initially asked me about. um, God, this is a lot of writing. Yeah, okay, hopefully there'll be simplification in here. 2 u1 squared, or 1 1. Not 11, 1 1. u1, u1 1 1. Oh, I hate this. This is... Ugh. It's convenient, but at what cost? U 1 2 squared 2u 1 2 2. Two u1n 2u1nn. I'm gonna do one more row. 2 1 1. Hey, X Ninja. Well, thanks for coming and saying hi. 2u 2 2 squared 2u 2 u 2 2 ugh 2u 2n 2u 2n n. This stream brought to you by U2. Have a free album by them downloaded onto your iPod, and you can't physically take it off your iPod. It's a sum on IJ. It sure looks like a sum on IJ. Every combination of IJ up to n, starting from 1. We can slam a 2 out front. I squared. I. J squared. J. Or E. Am I doing too much now? I don't know what I'm getting. I don't know what I'm doing, Color Cone. I thought I was writing all these at once. It's me trying to represent this. We do get some third derivatives in here. Uij squared plus Uij. Oh, I'm taking this way too far. You're right. I was making this too complicated. I was gonna write out this entire line. Yeah. How's 2026 going? Personally, worse so far. RAM prices are shit. Job market is shit. Age verification, censorship stuff not looking great. But that's partial derivatives. Yeah, my 2026 is going all right. Some good things, some bad things. I'm not sure when you heard from me last, but I'm halfway through grad school. I'm going for a master's in applied math, and I'll be graduating in June. Yeah, I'm sorry that things aren't. I'm sorry that so many things are going wrong for you so far. I hope it turns around. And yeah, these are partial derivatives. I'm working on a problem for my PDEs class. We're talking about harmonic functions and subharmonic functions. Now we split the first sum in 2. The first term is Gucci, so we only care about the second term. This is the Laplacian of U? Is it? No, it's or that's not no, Laplacian doesn't have mixed partials. Oh yeah, oh my god, that's wait, what is the first one? Why is it Gucci? Something positive. Oh, true. Okay. So we only need to worry about this being positive. Why should that be positive? Kind of wrote that in a weird way. It's 0? Why? Oh, wait. Okay, no, I should look at what you wrote earlier. Oh, there's a Laplacian hidden. Oh, that's what you're going for. And I guess we are assuming that we can interchange partials, but that's fine. Some I, ui, uh, wait, is it? Okay. Er, wait. Yeah, I'm just trying to verify with this double indexing that this is indeed a true statement. It should be though. There's like, and relying on derivatives being linear. That's fine. Yeah, what I'm doing in my head is just I'm plugging in actual numbers for I and making sure it works for all these different situations. But I think it does. We do need a LaTeX extension for Twitch chat. It's been an idea I've had for forever that that chat up there should render LaTeX when people type it. I need to figure out how to actually make that. But that's like been something I've been wanting to do for a long time. Chrome extensions? No. What series is that? Oh, this is unrelated to the harmonic series, as far as I know. Okay. So I believe this now. Do 0. Okay, nice, Colorcom. Thank you. We're talking about harmonic functions, which are a certain type of function. It's a function that satisfies Laplace's equation, which I don't know if you know what that is. But as far as I know, they're unrelated to the harmonic series. We did end up with a sum of Laplacians, so that's where things got confusing. It's just a complicated problem. No, Ninja. I mean, where did you get that symbol from? As far as I know, you'd have to copy paste the symbol from somewhere else if you want like a delta like you just did. You can now work with multiple people on Notability. I assume that's an app for note taking. I don't have to LaTeX my homework. I will LaTeX my homework though. Oh yeah, so unless you have a special keyboard, you can't do that by default. That's interesting to know that that exists though, Ninja. With Chrome extensions for the emote? It's not just watch the stream though. That feels stupid. Why what like unless it's at a terrible time for you, I guess, but I'm planning to watch the stream the next time it happens so I can get that emote. Oh, that or I think it's like Alt and numpad will do that. I used to have it memorized for like E with an accent because uh the executive when I used to work at my office job, the executive that was like closest above me had an accent in his name and he preferred to have it written there and didn't like when people got lazy and just did a regular E. So I eventually had that code memorized. Yeah, thank you, chat, for bullying me. It's not quite. I don't think it's entirely done, but we have ideas for all these now, so that's a huge amount of progress. I was online dating a French girl. What? I can confidently tell you, I've never online dated a French girl. Okay, I'm done thinking. You can't make me think it anymore. What questions are left? I've got to um I've got to actually like write out 3 and make sure that I understand what you sent me before color cone. Uh, did we do 4? Oh yeah, we did 4. What about 2? Oh yeah, 2. I still want to try out my Taylor thing for 2 because of ease with accents. Oh, I mean, I just told the whole story of why I had ease with accents, but that'd also be an excuse, I guess. I don't know if today will be a Daisy day for me, but whatever I do, I'm not going to do it on stream. Is this the fastest I've done my homework? For like a difficult class, like I'm not comparing it to like an easy class. Uh, Probably. Maybe one of my early complex analysis homeworks were pretty fast too. But this is completely chat carrying. If I was doing this under my own power, I would still be stuck on 2 by now, probably. Okay, save. Ooh, don't hit A. Okay. All right. Let's look for a raid. Ninja, anyone else who's here on YouTube, thanks for being here. I'll cut the YouTube stream off here.